Everyone, my name is Omkar and I'm a solution architect in Redis. And today I'm here to answer one of the questions that came up, how to use Redis with LLMs. That's just one of the topics that we'll be covering in this session. So today I want to talk about how Redis integrates into the new age GenAI solutions that we are building. And just before I get into the meat of it, I just want to introduce Redis for people who have not used it before, just in a single sentence. Redis is a in-memory key value store. It is the fastest database out there. And we don't take our word for it. You must have seen this slide before. We are the most admired, most popular, and most launched database on the planet. The primary reason for using Redis is speed, and you can see that is the first pillar of Redis as a database. I heard something about benchmarking as well. So we have a public benchmark of 200 million operations per second with sub-millisecond latency, with 100 million reads and 100 million writes per second. That's where we stand. But more than just a NoSQL database, if you just go to our GitHub repository, you would see that it is a data structure server. So although caching is our bread and butter, we do that really, really well. But there are more than 10 other data structures which cater to different other use cases. And one of the use cases is just vector search that we'll talk about today. But there are many other data structures that you can use to make your applications very flexible. Some of them may be lists for job management, hashes for profile management, state management, and so on. So there are many other things you can do with Redis as a database as well. And today we are going to talk about vector search, and that is the newest addition to our indexing engine and how we integrate that into our modern GenAI architecture. Specifically today I'm going to talk about recommendation engines, but probably just give you an overview about what are the other GenAI use cases that we do as well. I also have a demo to show you, so you can actually see a GenAI application working. So before we start, let's try to understand what this vector search is about. And I mean, for last couple of years, you may have been hearing this term vector database a lot. So I just want to introduce what is a vector first. In layman terms, I'm not going to get too technical. So in layman terms, a vector is just array of numbers stored together in an array. So here you can see that I have like an array of 1.0, 3.5 and so on. Like you can have n number of numbers in a single array. So why is this even important? It is important because we can represent any object out there like text, image, audio, video, whatever, in terms of these arrays of numbers, which are then called as vectors, which represent those objects at a nuanced scale. These are typically created using an AI model. So today I'll be using an OpenAI model to generate my embeddings. These are also called as vector embeddings. So I'll be using OpenAI, but of course there are many other models that you can use to create these embeddings and so on. Why should we create these embeddings? Because vector search is basically nothing but finding distance between these two arrays of numbers, mathematical distance between these two arrays of numbers. Now there are different kinds of distances. Maybe you want to find the angle between these two arrays of numbers, and that is a cosine distance. You have inner product distance, you have other Euclidean distances and so on. A little more technical, but at a high level you are just finding distance between two arrays of numbers. So that capability is now available in Redis, and that combines with our always the pillar of Redis that it has to be fast always. So that is what vector search is about. Specifically in terms of recommendation engines, why is vector search important? When you do a vector search, when you find these similar arrays of numbers, you are basically finding similar objects in your vector space. And that is a core component while designing any recommendation system. Okay. So talking about traditional recommendation systems, before we talk about integrating vector search and so on, Again, this is like a high level overview of the existing recommendation systems, which work pretty well, to be honest. So there are like three types that we talk about. One is content-based filtering, one is collaborative filtering, one is an hybrid approach as well. So when we talk about content-based filtering, it is to understand, you can imagine that you are, let's say, going to Netflix and watching a movie and it's from an action genre. What if we decided to recommend the next movie to you based just on genre, but based on that keyword genre, you know? So you would get all the action movies recommended to you. That is one way of doing it. Again, it has its own drawbacks. The biggest drawback being that you'll never be recommended anything that you have never explored. So it's based on user interaction. So that is one of the drawbacks of this system. The second is collaborative filtering. When we talk about collaborative filtering, it is a little more sophisticated. So it's based on the wisdom of the crowd, which means that let us say you have bought a credit card. Now let's say there are 10,000 other users in your system who had bought the same credit card. What is the next step that you recommend to this user? It may be based on what the other users have done before, you know. So that is called as collaborative filtering or collaborative recommendation systems. There are various names for it. But the biggest drawback, like you see on the screen, is to leverage this system, to leverage wisdom of the crowd, you need a crowd. So if you are just starting your application, you may not be able to actually get these recommendations very easily. So that is called collaborative filtering. And finally, there is a hybrid approach where we combine both these approaches to get a more nuanced result. So what is the issue? There is no actual issue, but probably a way of implementation for the hybrid approach. It may be that when you combine these two methods, you have to score the results yourself. You have to measure the weights yourself. So you have to basically build a handcrafted algorithm to build this recommendation system, which may be tedious at times, difficult to manage and so on. And that is where we add this vector search component, where the algorithm is taken care of already by this vector search capability. So in vector search, what we do is we represent a user as an embedding, represent the preference as an embedding, represent different kinds of objects as their embeddings, and store them in a vector database. Now this AI model that you use, you pointed out, we have to carefully think about what AI models we are using and make sure that they are represented correctly in the vector database. But once that is done, you can easily find the similar objects based on just a single operation called as vector search. So at a very high level, I would say the features of a modern recommendation system, and this is from our public blog that we did with NVIDIA in their Triton platform. A real-time online recommendation system as opposed to an offline recommendation system has these 4 steps, that is retrieval, filtering, scoring, and ordering. Now, where Redis really fits in this entire scenario is the first 2 steps, that is retrieval and filtering. Although you can do kind of ranking in Redis, usually that is done again by some AI models to fit your use case. So first 2 steps is where Redis really fits in as a vector data, or a vector database fits in actually. This is a very high level diagram of a recommendation system. Let us say that there is a guy called Bob. He watched the movie Harry Potter, and what happens after that? How do you give recommendations to Bob? What happens is you first update Bob's profile to store his preferences. Now Redis offers so many data structures. You may choose to use whichever data structure suits your needs and how you want to represent that object in space. But ultimately, that object is going to be compared with a vector data, embeddings in a vector database. Now this vector database contains all your user and movie embeddings. We'll see in today's demo, I have like embeddings about 45,000 movies. So after you do a vector search, you kind of do 2 operations. You find users, first you find users who are similar to Bob. and then you find movies that are similar to Harry Potter. Then you combine these two recommendations, and then finally give a personalized recommendation to Bob. Now, although this looks, this is a very high level diagram, so even in this, there are certain enhancements that you can do. First, you see a block of rule-based filters, and this is again probably the biggest advantage of using Redis. The way we give recommendations in the the pipeline above and below is also by using filtering in conjunction with vector search. So it is like metadata filtering. Let me give you an example. So if you have watched, if you find movies that are similar to Harry Potter, but also you want to add another filter, maybe I also want to suggest movies from a certain director or having certain cast, actors, then you can add those rule-based filters as well along with your vector search. And this is called hybrid vector search, which is also offered in Redis, which helps you, make your recommendations more nuanced or more personalized based on the user's profile and so on. And finally, you can combine and rank the recommendations. Usually that is done outside Redis, so you can do that and give the personalized recommendation to Bob. So this is again a high level diagram, but even in this there is a major problem, okay, and this is a problem with GenAI applications in general. If you are going to use any GenAI in this, the problem is that two problems, cost and performance. If you are going to use any LLM in this entire process, you would know that if you have used LLMs before in any of your applications, you would know that LLM is probably the slowest step in your entire real-time application because it takes time to generate a response and so on. The other problem is scaling. If you have like 10,000 similar users like Bob coming in, do you really want to go through these pipelines over and over again? Because you know that recommendations are probably going to be the same for these kind of users. So it's not only computationally expensive, but also you are going to spend real money when you are using LLMs over and over again to use those tokens and generate responses over and over again. You will see an example of this as well. So in order to mitigate these two problems of cost and performance, we have something called as semantic caching. Now semantic caching, you have heard caching before. So caching is just like you store data in like a cache, like Redis. Whenever you have a query, you first check Redis. If the data is available in Redis, you return the data with a very fast speed. And if not, you go back to the database and return the results from there. Of course, there are many other caching patterns, but this is a very common one. Semantic caching is very similar. In fact, it's a logical extension to regular caching. It's just that in regular caching, you are searching for exact terms in your cache. Did this exact query come before? Have I cached this exact query? In semantic caching, you are just going to see if the data that I've stored, if the queries that I've stored have meanings which are similar to the queries that I've cached. So it is a search based on meaning. It's a vector search. So instead of a regular lookup, it's a vector search that you do in your cache that you have stored. And a very interesting side effect of this, again, like I want to digress a little from recommendation systems here. Whenever you are building a GenAI application, you may have seen this, that there are no sort of guardrails in an LLM, right? So I'll give you an example. Let's say you're building a chatbot and it's a fintech chatbot which is answering questions about investment. And if I ask the chatbot, who is the president of India? Probably it will respond if it has the data. You don't want it to, So in order to make the LLM take that decision in split second, semantic caching is also used to implement some guardrails where you can have like certain questions that you don't want the LLM to respond, don't want to spend unnecessary compute and money, and also be inaccurate. So that is also something that is done using semantic caching, where you define this paths for the chatbot to respond or not. That is called semantic routing, which we can probably I'll discuss in future sessions. So with semantic caching, it is just a simple addition of a semantic cache where instead of just going directly and doing these vector searches, you first check your cache. If similar queries are available, give the recommendations directly from the semantic cache. And again, I'll show you an example of this as well, real time. This is the question that I'm here to answer. Why Redis as a vector database? And in a word, I would just say performance. Because vector search is available in many databases. So why Redis as a vector database is simply performance. And I mean, of course, there are many cases for that. Like if there has been some research that if you are more than 100 milliseconds, that's the time it takes to blink your eye. And if your customer experience is taking more time, you're probably having an outage in these scenarios. So beyond cache, I think we saw the mention before as well. Redis was always known as the world's best cache out there. But beyond that as well, we have added so many features which are also very real time that you can enhance your applications to great scale there. One of the things that I want to draw your attention to is JSON and search. So I know today we are talking about vector search, but that is just a subset of search in general, right? So imagine this, that let's say you have a document database somewhere and you want to cache some documents in your Redis. You can directly do that natively in Redis now, which means that you can create sort of a in-memory document database inside Redis. And not only that, you can index it and search through it as well. And there are all kinds of searches like full text search, numerical search, everything, geo-based searches and so on. Vector search is a subset of this feature of indexing and searches that we are talking about. Formally, this is our vector database. So these are the features that are offered currently by our vector database. We offer storage format of hash and JSON. For people who are familiar with Redis, you would know that hash is very similar to a row in a table, right? So basically, if you're coming from a RDBMS background or your backends are RDBMS, probably you can use the hash format. If not, you can also use the JSON format for unstructured or semi-structured data that you have. These are the different indexing algorithms and distances that I talked about before. We have HNSW and flat indexing, and also we have these 3 distance metrics that we were talking about before. I think like I mentioned before, probably the most powerful feature here in order to personalize your experience is the hybrid search, where you can combine all kinds of searches, full text search, geo searches, numerical searches, all of that into your vector search in one single operation with this Redis search module, and that gives you a great experience as well. Of course, Redis Enterprise is an enterprise database, so we come with a lot of these management features as well. The most important, again, being role-based access control, because security is something that we don't talk about that much when we are talking about LLMs and so on, but that is also a very important part. So if you have a vector database with these features, you can probably give subset of your users certain, access to only certain documents and generate only certain kinds of results. So that is important from governance perspective as well. Finally, we have always been developer centric. So we have developed a library called as Redis Vector Library. It's based in Python. So the reason we developed it is to make the experience for you to build a chatbot frictionless. So you can actually build a chatbot, not just a chatbot actually, just a GenAI application in general, in less than 50 lines of code with Redis VL Vector Library. And we have abstracted all of these things like creating an index, maintaining an index, and so on from the developer point of view. So you can just focus on your business logic there. So do give it a try if you have not tried it out before.
Is there a link?
Oh yeah, I'll share all the links at the end of this session. Probably I'll ask someone to send the links. These are the 4 major use cases that we tackle. Document search. You have already used regular search, where we search based on keywords, fuzzy search, and so on. Now we search documents based on the meaning of your query. So based on natural language and so on. So that is document search. Recommendation engines we talked about, and semantic caching we talked about. I mean, if you have built any chatbot in AI, you would be familiar with this term RAG, retrieval augmented generation. That is where also a vector database comes into play. And again, like to talk a little more about RAG, why RAG is important is, again, there are two major issues that RAG is trying to solve. This is again an issue with LLM. LLMs are designed to give you a response, not the correct response, a response. Most of the time it can be a response, like the correct response, but it can make up stuff as well. And that is what is called as hallucination, right? So that is again something that we are trying to solve with this approach. It is not entirely based out of Redis, but it's an approach to build like GenAI application where Redis plays a very critical role of giving you that sub-millisecond latency. And the second thing is out-of-date data. So if you have used ChatGPT before, I mean, you would know that you always would get responses like, hey, I'm only trained till September 2021 and I can't respond and stuff like that. So that is again something that we are trying to solve with having a vector database where you can keep updating the information in a vector database and your LLM will still be able to answer the questions which are like very recent events and so on. I think we have covered most of this, but I'll just reiterate the challenges and their solutions from a Redis perspective. Cost, if you are, like I said before, if you only use LLMs, don't use any kind of semantic caching, probably going to spend a lot of money going back to LLMs over and over again, or even fine-tuning models, spending effort there. We can solve that with vector search and semantic caching to some extent, of course. Quality, I was talking about RAG just now, and that is where RAG approach and hybrid search comes into play. Performance, semantic caching again, if you want to make your customer experience really fast and also scale, that is something which Redis will help with as well. And finally, the security that we were talking about before, role-based access controls and also semantic routers. So that is from the presentation perspective, but I also want to show you a demo of, I mean, it's like a application that I built so that you understand what we were talking about till now. So let me show you a demo of some of these features. Okay, so now this is not entirely based out of recommendation systems. These are actually to demonstrate all the 4 pillars of GenAI application, that is document searching and how to give recommendations and semantic caching, and finally just a RAG approach in general, how it works and so on. So before I even type a query here, I'll show you what we have stored in Redis. So in Redis, I have something like 45,000 keys here. Sorry, I think okay. So you can see that in, I think it's not visible. Please let me know if it is visible and so on. So in Redis, I've stored, this is running on my local system, by the way, in Docker, Redis stack. And there are like 45,000 movies that are loaded into this applications along with their OpenAI embeddings. We have like various features like IDs, title, language, overview, and like many metrics that are measuring this movie. It's a public data set that is available on Kaggle. And what we are going to do with this demo is try to do vector search on this data set. Okay. By the way, if you have not seen this tool before, this is called Redis Insight. It is, if you are using any form of Redis, this is a free tool which you should definitely use. That gives you a lot of visibility inside Redis, gives you a visual representation of Redis as well. So if you have not downloaded it, please do. So the first part is which movie was that. So let's say I give like a plot line, faint plot line. I want to see if my system can recommend some movies based on just the plot line that I give. Usually this is what happens when you are like, hey, I want to watch a movie which has some of this and some of that. What kind of movies are available? So I'm a Harry Potter fan, so I'm just going to type like a young wizard living under the stairs. Goes to a oh yeah, I mean, so basically I entered the prompt, a young wizard living under the stairs goes to a wizarding school, and the first response that I got was Harry Potter and Philosopher's Stone. So basically you can see that this is not exactly what is there in this description. It is basically capturing the meaning, comparing these two based on certain distance that I have already defined, and based on that it is giving me a recommendation. So I'm not entering exact text, I'm just entering what is like in natural language, what do I want to see and so on. And of course, again, like I'm probably repeating this many times, but the entire point of using Redis here is the speed. So this you can see was extremely fast, and just that probably is the hallmark of Redis here. Now this is more interesting, and this is where you'll probably see the cost as well. Not see the cost, but I'll tell you the cost. I'll just write the same prompt again, a young wizard. Okay, so before I press enter, it's the same prompt actually, but what this is going to do is now we are getting a little more serious in application development. So it is going to find the movie that is closest to this prompt. Then based on the description of the movie, it is going to generate a poster using DALL-E model. So you can see a poster has been generated right now. This is generated right now by DALL-E. But the problem with this is it costs $0.08 per image. So imagine if there are 10,000 users that are logged into your system at the same time. Let's say Harry Potter released yesterday, and today somebody is using your application. Most of them may be trying to generate its posters, right? If 10,000 users did this, you're spending like $800 a second. So that's the scale that we're talking about. And so in order to mitigate this, if you expect similar questions to be asked over and over again, what I've done here is, whenever this was generated, I just put it in Redis. So I'll show you probably how it looks like in Redis. Just the response and the query and its embedding. So I have made sort of a LLM cache here. So this is the thing that basically got added to Redis. You can see here, the difference here is compared to like document search, what is the difference is we have created an embedding for the prompt or embedding for the question, because we are going to try to find similar questions, not similar content. And the content is stored as it is. So whenever you have a similar question, we just give the same response back to the user. So let's try that. Like it took like 18 seconds to generate this image and find this entire process. If I, let's say, copy paste the same query or the same answer here and press enter, you can see the time has reduced to 0.5 seconds. And not just that, you're not going to LLM now, and you're just giving the response that is stored in Redis. Now this is an exact query that I copy pasted, but let's try similar queries. Let's say I remove the word young. So basically, whenever we have a similar query as well, so you can see I removed the word young. If there are spelling mistakes and so on, all of that is taken care of, right? So that is how we use semantic caching in a regular sort of application. Recommendation systems recommend movies. This is similar to the first use case, of course, just going through 45,000 documents and finding similar queries. The only difference here is you can combine hybrid search here. You can have different kinds of filters that are added to your vector search. So for example, I'm a Mission Impossible fan as well. So action-packed movie where Ethan Hunt and team pulls off impossible missions. If I do a vector search, a regular vector search, you can see that you get all these movies from our database very easily, very quickly. But what if I want to personalize the results? I want to say that, hey, I want to increase the popularity or probably increase the runtime and so on. It can be n number of things, like whatever metadata you have stored. And if I click on submit again, you can see that the results have changed quite drastically, in fact. But you can see the query. I know it's not visible here. Maybe I try to zoom it. But all this query is just one operation that happened inside Redis, like adding the filter and also doing vector search all together. And you can see it was like super fast as well. So this is how you kind of add filters to your recommendation systems. And finally, this is the most interesting sort of mini app that I've built. So if I want to create my own movies based on existing movies that are there, probably a pattern that we already see, but I can like combine plot lines of many movies. So I have added one movie, the Mission Impossible prompt, the Harry Potter prompt. I also added a Hindi movie, ZNMD. What if, I know you can't see the prompt, just take my word for it. It is a group of friends on a memorable road trip in Spain performing various adventure sports and so on. So I'm expecting ZNMD to be captured here. So what is happening in this app is basically the RAG approach. Whenever we click on submit, it will go back to my vector database, that is Redis, pick all the plot lines of the movies that are very, very similar to the prompts that I've entered, and then give it to an LLM to generate a completely new movie. Generating a new movie is not done by Redis. It is done by AI model. Where Redis plays a part is basically getting those similar movies really, really fast, making your application snappy. Okay. So when I click on submit, I'm hoping to create a completely new movie here. In the meantime, you can see the prompt that was issued to the LLM. I did a little bit of a prompt engineering here. You're an expert storyteller and so on. You can see all these descriptions are from your vector database actually. And then it is generating a movie on its own. Also using both the models here. So this is your new movie, The Secret of the Lost City. And basically the plot lines are all combined here of Mission Impossible, Harry Potter, and ZNMD. So basically this is how you use RAG approach to build your generative AI applications as well. I hope you found this interesting and useful.